Good afternoon, everybody. Welcome to class today. Third time's the charm. Took me 3 different buttons to hit to find the right button there. But we got the right one. We found it. Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you are watching live or you are watching the recording, I appreciate you watching. We're finishing up talking about Python today. We're going to talk a little bit more about our remaining things, right? We said that programming languages have 5 different things. That's one of the things that we said last week. We said they have input, output, math, repetition, and choices, conditionals. Those are 5 things that every programming language can do. In our supplemental video and in our last week's live class, we looked at the input, the output, and the math. This week, we're going to look at the repetition and the conditionals, right, to kind of wrap ourselves up, and we'll do a bit of a longer demonstration toward the end where we take several of these things and kind of put them together. Right, so just as kind of a review of some things that we talked about in that supplemental video, and we will be kind of jumping back and forth between the slide deck and a REPL a lot today. But just as kind of a bit of a review of what we were doing in that supplemental video last time, or that I sent out over the weekend, I talked about inputs in that video. And one of the things that we talked about there is that we can use the input function, which we see here, and we pass the input to a variable. One of the things that we talked about in the video as well is that we use a variable to hold data. A variable kind of creates a structure that we can use to hold data. We can kind of compare it to a shoebox or a jar or a bag. It's just this container that we can put data into, take data out of. We put a label on this data, right? And in doing so, we kind of create this symbolic relationship between the name that we put on this box and the data that's in this box. So, for example, like what we have here is our variable name, var_name. That would be the label that we put on the box. We have our input function here, and then in between the parentheses, in quotes, as a string. Right, one of the things that we said about a string is we can kind of think about a string as like, the party banners that you see where each letter is put up on a string. Our computer doesn't see words, it sees a sequence of characters. That's the message that we want to display to our users. And so the results that we get back are passed back to our user as a string. So in order to do math, we have to do some typecasting. Right, and so we see the typecasting. I demonstrate that to you in the input video in the module. I also demonstrate that to you in the video that we looked at over the weekend. There's too much stuff going on here. I have way too many browser windows open. Where's my Replit window? And then from here on out, I'll just close this window. But as always here, as we're starting to get coding here, we're going to start out with our shebang. So that's going to be #bang /usr/bin/env space Python 3. Right, and remember, as we've kind of said before, all that this allows us to do is kind of save our .py file to our computer, and if we have Python 3 installed on our computer, then we can double-click that .py file, and it will open up and run without us having to do anything special to it. And so we can use this input here. The first thing that we need for to be able to take an input is some kind of variable. So we can say user _ name, and we can set that equal to the input of what is your name. Right, and remember that what we put in here reflects how we want to see it on the output. Right, the words and things here mean absolutely nothing to our computer. It's just a sequence of characters. Right, so remember, when we think of string, we're just thinking of again the string of the banner with the string of characters at a birthday party, right? You have the individual characters that are just the individual letters that are just hanging up on a string. So the way that we see it in our output is going to look the same as what we type in here. Right? That's why I put this little extra space on the end of the line here. Because if I didn't put that little extra space there, when I run it here, I have what is your name? And if I go to type in Mr. Ramsey here, that M there is going to show up right next to that question mark. But if I put that extra space there, and we'll stop and run that, we see it gives me an extra space there, so I can go ahead and type in Mr. Ramsey. And we hit enter, and it takes that value and it stores it in this variable that we're calling username here. And then we can use that however we so choose. Right? So in this case, we can kind of do, similar to what we were doing last week, and we can just use some outputs here, like with our print statement, and we can print hello, and we can kind of concatenate that with the username, which in this case would be whatever our user enters in. Right, so in this case, if I type in, what is your name, and we say Mr. Ramsey, it'll return to us, hello, Mr. Ramsey. If, it's some other name, like it's, Sally, hello, Sally, right? It's just whatever we give to it, it'll echo back out to us. That's all well and good, right? We'll go ahead and comment this out. So that's 1, 2, 3 quotes at the top and 1, 2, 3 quotes underneath. Right? Remember we talked about, what this does last week. If we want to make a block comment, which is basically telling our interpreter to ignore this part, we put 3 single quotes or 3 double quotes at the top and bottom of the section that we want our interpreter to ignore. So that way we don't get a whole bunch of output. Right? So the problem is, what are we going to do with math, right? So if we say something like, oh, well, what if we wanted to take and make like a simple calculator, right? And say, oh, we're going to take 2 numbers in, we're going to add those 2 numbers together, we're going to give an output, right? So let's say here, oh, well, num1, our variable num1 is going to be set equal to the input of enter number 1. And num2 is going to be set equal to the input of enter number 2. And our result here, we can print out num1 plus num2. Like ideally, that's what we'd want to do, right? Instinctively, that's what we'd want to do. But let's see what happens when we do that, right? So it tells us to enter number 1. Let's say we enter a 12 here for number 1. And it looks like REPL's having a little bit of a connection issue here. So let's run that again. And let's enter a 12 here. When we enter a 12, and okay, now it's telling us to enter a number 2. Let's enter 54. And we get 1254. And so what's it done there? Why is it giving us that issue? Well, what's happened here is that we've not added our numbers. We've actually concatenated our numbers, which is what we did here on line 4 with hello and username and our plus sign. When we take 2 strings and we smush them together with a plus sign, that's called concatenation. When we take an input, what we're doing is we are taking back a string. So in order to be able to use that as a value for math, we need to be able to do what we call typecasting. And so there are actually 2 different ways that we could typecast this. We could typecast it on the input, right, which would be basically taking and wrapping the input in an integer typecast, which would be, it's behaving kind of strangely, which would be basically doing it like that, right, where we take and wrap an integer function, int, open parentheses, close parentheses all the way at the end. Or we could do it at the variable level, right? And I believe the example that I give you in the module actually does it at the variable level when I'm actually doing the math, right? So I could also do it like here in my output. And honestly, I think it's a lot cleaner to do it this way, right? Instead of, kind of having a function inside of a function inside of a function. But either way works. So I'm just going to leave it like this. Maybe I'll write a little note here to say, we'll just write a little single line comment here and say, int typecasting either way works. Right, so when you get this code later on, you can remember, okay, yeah, I understand, right? And to do math with inputs. Right, so now if I run this, we can take 12, and then we can take 54, and we get the value 66, which is what we would expect here. Right, so both of these things that we see here, this, hello Mr. Ramsey or hello whomever, and what we have here in terms of getting our value, both of these things are expressions, right? An expression is a combination of values, variables, and operators, right? So, we have addition operators or different mathematic operators. A value all by itself is also considered an expression. So even something just as simple as a equals 7 is an expression. Because, if I were to go into the prompt and type in just a 7, then Python would interpret it and give it back to me, right? Like, that was something that we were kind of playing with and practicing last week, right? If I did this, I get a 7 echoed back out to me, right? So that shows me, based on that alone, that is an expression. So when we type an expression at the prompt, the interpreter evaluates it, and evaluation means that, basically our interpreter just finds whatever the value that expression is worth. We can take several of these and put them together to make a statement. A statement is just a unit of code that has an impact, right? We've been practicing several of those. This is just kind of a definition of a term, so we'll just kind of gloss right over it. String operations. Let's talk about string operations really quickly, because we've already seen one, right? We've seen the plus sign operator, which we said was concatenation. And this only works when we're dealing with two strings, right? Or we're dealing with a string and something else that we can turn into a string. Because we can't perform math on strings, right? That's why it's such a big deal that the input that we get from our input function is a string, because we can't do math on strings. So that's why we need to be cognizant of that fact. So when we go into, try to figure out, okay, if I need to get a number from this input and I need to evaluate it and I need to do some sort of mathematical operation with it, or I need to compare it against another number, then I need to actually turn it into a number and not a string. Otherwise, my computer is going to think it's a string. It's going to think it's that ASCII value that we looked at previously in those charts, right? It's going to think it's that, the binary, the whole thing with that, right? And so in general, you can't perform math on strings, so it'd be kind of silly to try to add, subtract, multiply, and divide strings. But we actually can use our addition and multiplication operators on strings. Just when we use them in Python, they're not addition and multiplication operators anymore. We call them concatenation and repetition operators. And so with our concatenation operators, we've already seen an example of that. They actually allow me to take one string and put it together with another string, which is what we did in our example here, right? We took the string of hello, and concatenated it with the string that we got as a result of this input that we put into this variable here of what is your name, right? The name that we got from this question. So we use the plus sign there to give us that back. Let me expand this here so we can do some more here without having to wait on it. Repetition operator allows me to take one thing and kind of repeat it multiple times. That's my multiplication symbol. So if I wanted to say, and we'll revisit this kind of in a minute. If I wanted to kind of print a row of, say, stars, right? Like we can print an asterisk character. So I will print star or space, asterisk, space. And I can sit here and I can type that out and I can do that a bunch of times. And after a while, I can lose count of how many times I did it, right? And I can run that and I can get a certain number of them. And if I want to type more, it'll take me more time. And if I want to have a specific number, it'll take me a lot. Or I can use my repetition operator. And if I use my repetition operator, I'm just taking a string and I'm multiplying it using my multiplication operator by some number. Right? So I take a string multiplied by some number, and it's going to take that string and it's just going to repeat that same string over and over and over again. So it's going to take this string of space star space or space asterisk space and repeat it in this instance 8 times. Just like that. So now if I have to change this, then I can just change this value here, right? Maybe I don't want to do it 8 times. Maybe I want to do it 12 times. So instead of having to be so precise about counting how many stars that are in there, I could just go change that number. Or I could also change it with a variable, right? So I can have a stars variable and set it equal to, you know, some number like 12. Which would get me the same result. Or I can even go so far as taking an input from a user, right? So if we're going to take an input from a user, since we're going to look for a number here, we need to typecast it to an integer. Input, how many stars? And now in this case, I can say, well, give me 15 of them. And we get 15 of them. Right, and so then we get this repetition operator here. And so that's one of the ways that we can do repetition, but it's not really the way that we, you know, when we talk about the 5 things, when we talk about our input, output, math, repetition, and conditionals, decision making, you know, that is a way that we can do repetition, but that's not repetition in the way that we're really meaning it there. Right, when we're talking about that, what we're talking about is a loop. Which we will talk about in just a bit. But that is the essence of our concatenation and repetition operators there. I am moving a little quickly. My suggestion today is to kind of, you know, since I do feel like I have a lot to cover, you know, like imagine like if I would have, you know, kept the entirety of the other stuff in that I wanted to keep in today and do the demo that I want to cover today. I'd have to go even faster or have a super long live class today, which I don't want to do. I still want to try to keep this close to an hour, so I am moving kind of fast. My suggestion is to really take advantage of the recording today. You know, Take advantage of pausing the recording, right, which is the real big benefit of the recording. Is that you can kind of pause it and take things in and kind of follow along and do things as you go along, rewind it and go back through it, right? So what is a conditional? We've mentioned the idea of conditionals. Sometimes we want our programs to be able to make decisions. And if we want our program to be able to make decisions, then we use a conditional. So our conditionals create this sort of decision-making process, right? Essentially what we're doing is we're giving our programs the ability to kind of split off into a couple of different directions, right? If something is true, it goes one way. If something is false, it can go a different way. Right, so when we're looking at conditional execution, we are looking at something that is called a condition. A condition is something that can either be true or false. It cannot be ambiguous. Right, we will look at some examples of some Boolean expressions in just a moment. The syntax that we see here is if condition. A condition is a Boolean, a statement that evaluates to a Boolean value. So what we have here when we're saying condition is just pseudocode for this statement that evaluates to a Boolean value. What we're saying here is it could be something like, oh, if x is greater than 5, if y is less than 2, if x equals tree. Right? Like it could be any number of items. Right? And we have to have at least one statement inside of each branch of that tree that we want to create. If we want to have a true, we want to have a false. We can have other options if we want to, right? We can chain or nest and add some subconditions. So, if this is true, we can check something else to see if something else is true, right? And that's a subcondition. Now, there is one thing that I want you all to notice here, and that is this space right here. This space right here is incredibly important. This is a tab. This is a tab space. Our REPL will do it for us as long as we make sure that we include this on the line above it. Whenever we see a colon, like this in Python, that means that statement has more lines that belong to that statement. All the lines that come below that statement that are tabbed in, one tab, directly belong to that statement. So those lines that are tabbed in underneath this statement only happen if this statement is true. Otherwise, they do not happen. They get skipped. Right? So when you're done with this and you're done with what you want to include to be what happens if this is true, you backspace back to get rid of the tab, to get rid of that space, to where you're back even with the word if. Right? This is one of the trickiest things for people to kind of wrap their heads around as they're learning Python, is the tab indentation. Right? And it all revolves around all the different statements that have these colons. If it has a colon, it has more lines that belong to it. If it has more lines that belong to it, those lines are tabbed in, which is key. Boolean expressions are expressions that can only be evaluated to either true or false. They are not ambiguous. The example that we see here is 5 equals 5. Obviously, that is going to evaluate to true. Otherwise, they will be false. Right? Now, one of the things that we notice here is the equals sign. We use a singular equals sign for assignment, right? When we are creating a variable and we are saying this variable equals this value, we use one equal sign. When we are checking for equivalency, we use two equal signs. When we use one equal sign, it's like saying this equals this. When we use two equal signs, it's like saying does this equal this? Right, which is pretty important. And so we have all of these different relational operators that we can use here, other than equals equals. Right, equals equals is just one. Exclamation point equals means not equal. Greater than, less than, greater than or equal to, less than or equal to. Right, these are all the things that are available to us. And these are all relational operators. And so if the statement is true, as it is written, it will execute the code in the if statement. If the statement is false, as it is written, it will not execute the code in the if statement. Let's look at our code. So I'm going to use this same code here for printing the number of stars, but I'm only going to print the number of stars if maybe I say that my user puts in that I want 7 stars. Right? So we'll say if stars equals 7. Now right now it's having a fit, right? We see this red squiggly line here under print. That's because this print statement is not tabbed underneath this if statement. My IDE is expecting at least one line to be tabbed underneath this if statement. So I hit the tab key on my keyboard, and you can see it gives me this little dotted line here when I hit the tab key once. Any other thing that I want ran as a part of this if statement needs to be on the same level, right lined up with the P in print. If I don't want it to be ran as a part of the if statement, I need to hit the backspace key on my keyboard and back it up. Right, so now we're going to get an input from the user. It's going to ask how many stars. If I put anything other than 7, it's not going to do anything. Right, because it's checking that condition to see if that condition is true. So how many stars? Well, if I put 7, it's going to print out 7 stars. If I put anything other than 7, like if I put 13, it's not going to put anything. Now maybe I want, greater than or equal to 7. Now anything that's 7 all the way up to positive infinity, it'll print those out. Right, which is beneficial. So it's more than just the 1, 7, right? So now it's greater than or equal to 7. So if I enter 6, it won't do anything. If I enter anything that's 7 or higher, like 13, it'll print them all out. Now, if I want to have something that happens in every other case, which would be an else, right? Else. I can type in else here and put a colon after it. Right? We can see my E in else is on the same level. It's lined up directly with the I in if. Right? My term else here basically means all other conditions. So if any other condition is true besides my if statement, then this will run. I can just print something like, thank you. So now, since my if condition is greater than or equal to 7, I can run that. If I have anything that's greater than or equal to 7, like say 8, that'll run. But then if this statement is not true, based on what was entered in, like maybe if I entered in 5, which is not greater than or equal to 7, it'll run my else condition and give me false, which is pretty good, right? Gives me more options and more opportunities. And I mean, that's kind of the thing that we're seeing with all of this stuff, right? Is that we're seeing the ability to get flexibility, the ability to get, more input, the ability to have more depth and bring more to our programs here. Now, before we can talk about loops, let's talk about reassignment and updating variables, because kind of the idea of reassignment and updating variables is a big one for loops, right? Because basically, when it comes to like writing a program, I can do one thing and I can copy and paste it and I can do it over and over and over again, but I don't want to do that, right? Generally, I had always heard that, programmers are kind of lazy. But actually, earlier today, I heard somebody say, programmers think lazy. And I was like, you know what? I like that way better. I like that way better. The idea that programmers aren't necessarily lazy. Programmers just kind of think lazy. So it's a lot easier for me to write a couple lines of code that can do something over and over and over again for me than it is for me to, take and rewrite a bunch of the same code over and over and over again. Right? So the idea of reassignment becomes important. Once I create a variable, one of the big things that we discussed about a variable is that, it's like a box, right? Like once I put a item into it, it's not just stuck in there. I can take it out and I can put something new into it. So if I have a value in there, I can take that value out. I can add whatever I want to that value, right? So like in this instance here, we can see like, x equals x plus 1. What does that mean? Well, whatever value that was in x before, I take that value out, I add 1 to it, I put it back in. So if 3 was in there before, I take 3 out, I add 1 to it, that becomes 4, I put 4 back in, so now the value that is in x becomes 4. So now I can count, right, which makes a loop important. So a loop takes this idea of a condition that we've been talking about here, where we say, we got this condition that we can use. It checks to see if something's true or false. And instead of just checking to see if that thing is true or false one time, like an if statement does, and deciding to do a thing one time, our loop's just going to keep doing this thing until that condition becomes false. And so that's great, right? Instead of just, doing things once and stopping, we can keep doing this thing until our needs are met. And so that's where that reassignment comes in such importance here. Because we need to have something that we can use to count or use to be able to kind of figure things out and move things. Right? Because when we talk about this, we talk about iteration. And basically, you see a lot of words here that talk about iteration. When we talk about iteration here, we're basically talking about definite iteration or indefinite iteration, kind of what we're doing here for our purposes is going to be definite iteration, right? because we're going to have a specified number of steps that we're going to be taking. When we really look at it, right, like this is a lot of, that's the wrong key. When we really look at it, right, when it comes to iteration, what we have here is we have a starting line, we have a finish line, and we have a certain amount of steps we need to take to get there. Our starting line is a particular number. It could be 0, it could be 1, it could be 2, it could be whatever number we want it to be. Our finish line is some number in the future, right? It could be 10, it could be whatever. Right, and then each step here is our reassignment values, where we're taking some counting variable and we're adding some value to it. Give me just a second here. So if we look at, say, our program here, we can move our block comment. I really want to try to get done within an hour and have enough time to do the demo that I want to do. So let's do that. What I'd like to do is I'd like to create a loop here, and I guess I should probably show the while loop example on the screen, right? So our while loop looks like this, right? Our I value here, this I variable. Remember, we can call our variable whatever we want to call it. I called it I here. I might even call it S or start in the example that we do. That's our starting line, right? Our 6 here, that's our finish line. This point here, that's the number of steps we're taking. So each time we go through here, we're just taking one step toward the finish line, and we're incrementing this value of I. So the first time through, I is 1, so we'd print 1, I, and then we add the 1 to the value of I. We reassign and increment this value of I. So we can just do an example that's like that really quickly. And then we'll do a slightly different example here. Right, so we can say we're going to start at 1. And we're going to say while start is less than or equal to 10. Let's count to 10. Right? So there's our colon again. Right? We said that when we have a colon, that means that there's more statements that belong to this. Right? We said this is just like an if statement, except that, instead of just checking this condition one time, we're checking it multiple times until this condition becomes false. So I'm going to hit enter here. We see that Replit automatically tabs me over. I'm a little bit further to the right than the W in while is. I'm going to print the value of start. And then I need to increment that value in start, so I am actually taking a step. If I don't do that, if I don't increment that value in start, I'm staying in place. So that value never actually moves. So I need to say start equals start plus 1. So I can take one step every time. If I want to take 2 steps every time, I can do that. 3 steps every time, so on and so forth, right? But if I just want to count to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this, right? So if we run this, that's what we get as the result, right? So the first time we go through, start is 1, we print and we get 1, we add 1 to the value of start, it reassigns it to a 2, it jumps back up here, 2 is less than 10, prints 2, so on and so forth until it gets to 10. 10 is less than or equal to 10 because 10 equals 10. So it prints that out, it adds 1, then it becomes 11. 11 is no longer less than or equal to 10, 11 is greater than 10, so it stops, and it would move on to the next thing. Right, to kind of make this work with our stars, right, just so you don't think it necessarily has to be the numbers on the output. I can say, oh, start. Let's set our start value. Let's call it S this time. Let's even make it something. Let's start it at 1. And let's make our end value, we'll call it E, an input. So since it needs to be something that we need to compare numerically, we need to make it an integer. So this will be input, enter end number. And so now I will say, while or as long as S is less than or equal to that ending number, whatever that user defines, we will print an asterisk, right, a star, with our repetition operator times the value that is currently in S. So we'll kind of build a little star triangle. Because first time it'll be 1 star, second time it'll be 2 stars, third time it'll be 3 stars, so on and so forth. As long as we increment the value of S, S plus 1, right? So S starts as 1, E starts as some unknown number until our user enters it. So while 1 is less than or equal to E, the number of stars, we get that printed out, we increment the value of S, and it will give us a little star triangle. Right? So let's say our user enters 9. We get a little star triangle that looks like that. And this can be as big as we want it to be, or as small as we want it to be. So I'd like to do a little demonstration to kind of wrap us up today. Just to kind of take several of these things and kind of tie them together, right? So I'm going to send you all this file along with the recording today. But I'm going to create a new Replit here. So remember, from the Replit homepage, you got this button here, and this button here. All those options to create a new Replit. From here, you're going to search templates, Python, and you want the one that's just regular Python. And I'm going to call this one a simple program. Right, and I'm just going to try to do a few things here. Just to kind of take all the different things that we've been doing and put them into one program. So the first thing that we said we want to do is we want to add our shebang. We're going to do that in every program. So that's #bang /usr/bin/env Python 3. And again, just remember, just to reiterate, that this really doesn't do a whole lot for us in terms of our program itself. All it does is it, if we save this .py file to our computer, and we have a Python 3 environment installed on our computer, we can double click it and it'll just run automatically. Now let's say, let's see, let me just try to think of some stuff here that we could do. Let's say we want to take a number from a user, right? We'll take an input of a number from a user. If it's If it's a number that's bigger than 10, maybe we'll just print out something like, I don't know, that's a big number. We'll just print out that's a big number 3 times to our console. That way we can get an if statement and a loop in there. And if it's less than 10, we'll just print out the number 5 times to the console. Right, so the first thing that we'll do is we'll take a number. So we'll create some variable num and we'll set it equal to, we can go ahead and change the integer value of input, enter a number. All right, so now we're taking a number from a user. So we can say if num greater than 10, right, let's say greater than or equal to 10. Right, so now, since we have that colon there, so this is our condition. So this is the condition that it's going to evaluate. That's going to evaluate to be true or false. If it's true, then what is underneath this conditional statement is going to be evaluated and ran. So we are going to create a variable here for our while statement, and we will say, we can just say x equals 1 while x is less than or equal to 3. Right, we said 3 times. Right, we need to make sure those are side by side or else it won't know what I'm talking about. And we're going to put a colon there. Right, now notice here, right, I have one tab for my if statement, and then another tab for my while loop. Right, because we have one colon here and one colon here. So if it belongs to my while loop, it gets one tab for the while loop and one tab for the if statement. So we're going to print that's a big number. And we're going to increment that value x. X equals x plus 1. Right? So if this runs, x is 1, 1 is less than 3. That's a big number. Adds a value to 1, that becomes 2. 2 is less than or equal to 3. Prints that's a big number. That's all well and good. If that runs, prints that's a big number. 2 plus 1 is 3. 3 equals 3, so it still meets this condition. Prints that's a big number. Adds 1 to that, becomes 4. 4 is no longer less than or equal to 3, so it stops. And that does everything that we said we'd do there, right? We said that if it was bigger than 10, right, we'd say we'd do this conditional statement where if it was bigger than 10, we would do this loop where it would say, oh, that's a big number. We could do that 3 times. So if it's not bigger than 10, it's going to be smaller than 10. So we know that if we have one if statement that covers half of our conditions, we can use an else statement to cover the rest of our conditions. And we can say else, and we can basically do the same thing here, right? X equals 1 while x is less than or equal to, let's say, 5, right? We can just print the value that is in number. Just print that number that we got. We can print number, and then we can increment that value of x. X equals x plus 1. And we already know how all that works, right? So basically that's all we would need to do here. So that's kind of a good example of kind of everything that we've done so far, right? We see outputs, we see inputs, we see math, we see repetition, and we see conditionals, right? We see all of the things that we talk about, that all five of those things that we've talked about that every programming language has. And we see an example of them right here in this one singular program. And I know I did that pretty quickly. But again, I don't think anybody's here with me live right now, which is probably a good thing. I think probably all of you are enjoying your fall breaks, which is probably good for you all, you know. It'd probably be better to kind of take this video in as a recording as it is, just so you can kind of take it and pause it and look at these things. I wanted to get this video done within an hour, and that's what we've done here. I've also covered all the material that I feel like we, you know, that we need to cover here. You know, you take this plus, you know, kind of what we covered in the module, and, you know, we did all of this over 2 weeks. And, you know, the big thing that, you know, I kind of want you all to kind of get out of all of this is, you know, that a lot of this stuff is, you know, there's a lot of big topics that we cover, and that, you know, you kind of need to kind of pace yourself, you know, over the, you know, if I say, you know, we're taking 2 weeks to cover this module, don't try to rush in there the first week and try to get everything done the first couple of days. You know, it's probably not going to be a good time. You know, just take your time over the 2 weeks. Try to take it in. Try to learn it. You'll get more out of it that way. But that's all that I have for you for today. So with that being said, I'll thank you for watching. If you have any questions, please let me know. And we'll see you next time.